Hi viewers, welcome to my channel. Today's our topic in chemical equations, making chemical equations more informative. Making chemical equations more informative. So after writing chemical equations, we have to know about uh, their physical state, whether any heat involved or uh, heat released, or if any gas evolved, or if any precipitate formed, so that every change included in the chemical reaction we have to represent while writing the chemical equation. So then our chemical equation becomes more informative. So how can we write our chemical equation more informative? Means by expressing their physical state of the reactants and products. Either they may be in solid state, liquid state, or gaseous state, are in aqueous state. So we have to represent their state of the substance beside of the formula of the compound or symbol of the element. Okay, and heat changes to complete a particular chemical reaction, heat involved, or some of the chemical reactions heat may be released. So either heat involved or heat liberated we have to represent while writing the chemical equation. Okay, so by looking the chemical equation we have to come to know the state of the substances and also whether the heat involved to complete the chemical reaction or the heat liberated during the chemical reaction. Some of the times during the chemical reaction gases also evolved. So by looking the chemical equation we have to come to know the particular substance is evolved in the form of a gas. Okay, and sometimes during the chemical reaction some of the substances formed as a precipitate, means they do not dissolve in the solution, they form as at the bottom of the test tube, so that we called as a precipitate. So if any precipitate formed, if the substance formed as a precipitate, we have to use the symbol and represent while writing the chemical equation. So while writing the chemical equation, all these informations we have to include their state, means physical state, either solid, liquid, gas, or aqueous solution. Heat changes, heat absorbed or liberated, depending on the absorbing and liberation. We have to set the equations as exothermic or endothermic. Okay, if any gas evolved, if any precipitate formed. So how do we represent all these? Informations while writing the chemical equation? We have to look at. Okay, the first one is we have to express the physical state. Okay, to make the chemical equation more informative, the physical state of the substance may be mentioned along with their substances and products chemical formula. So the states, we have the states of matter: solid state, liquid state, gaseous state. If the substance is a solid, the physical state we have to write as S within the bracket beside of the formula of the compound. If the substance is a gas, for example hydrogen gas, oxygen gas, so if it is in the form of a gas we have to represent its state as small g within the bracket. If it is a liquid like water, okay, their state we have to represent as a L. Okay, solid means S, gas small g, liquid state means L within the bracket beside the formula of the compound or symbol of the element. We have to represent their physical state. Okay, if the substance present as a solution in water, sometimes the substances will present as a solutions in water. So in such cases the substance physical state we have to represent as aqueous, and they that physical state of the substance represent while writing the chemical equation as a small a and small q within the bracket. Okay, if the substance present as a solution, okay, sodium chloride solution we have to say, means sodium chloride dissolves in water, means that is sodium chloride solution. So sodium chloride solution, its physical state we have to represent with the aqueous aq within the bracket aq we have to write. Okay, like this way we have to express the physical state, then our chemical equation becomes more informative. Okay, the second one is expressing the heat changes. whether the heat liberates or the heat absorbed during the chemical reaction, the heat amount of heat energy will represent with the capital Q. If heat liberated during the chemical reaction, we have to write the symbol of Q at the product side. Along with the products, heat liberates means at product side we have to represent the amount of heat evolved with plus capital Q. Q represents here heat energy, amount of heat energy. Okay, if it liberates along with the product at product side with plus Q, or in some cases to complete the chemical reaction, some of the chemical reactions involved heat energy. Okay, involved heat energy. So that heat energy along with the reactants, the heat energy, amount of heat energy absorbed to complete the chemical reaction, we have to write while writing the chemical equation. We have to represent amount of heat absorbed at reactant side with plus Q. Okay, if the amount of heat energy absorbed to complete the chemical reaction, such reaction we have to called endothermic. Heat is entering into the reaction to complete to progress the chemical reaction, so such reactions are called endothermic. Here in some cases um, heat is liberated at the product side, we have to represent with plus Q. Exit means to come out, so exothermic, heat is coming out during the chemical reaction, so such reactions we have to call as what, exothermic reactions. Depending on the amount of heat absorbed or liberated, we have two types of reactions. If the heat liberated exit, such reaction we called as exothermic. If the heat absorbed, if the heat entered to progress the chemical reaction, such reactions are called endothermic reactions. Okay, plus Q at product side or minus Q at the reactant side represents minus Q, and plus Q at the product side or minus Q at the reactant side also exothermic. Minus Q at the product side and plus Q at the reactant side also endothermic. Okay, here plus Q at product side means exo, or minus Q at the reactant also represents exothermic. Minus Q at the product side or plus Q at the reactant side, if we represent also, it indicates a endothermic reaction. So this is the second state of second type of information giving while writing the chemical equation. The next one is expressing the gas evolved. While writing chemical equation, if any substance evolved in the form of a gas, okay, we have to represent beside the symbol of substance with upward arrow. Upward arrow indicates as what, the substance evolved in the form of a gas. If any gas evolved, we have to represent with upward arrow. Upward gas evolved means it coming out in upward direction. That's why we have to represent gas evolved with upward arrow. Okay, and next in following equation, if we can look at zinc plus sulfuric acid gives rise to zinc sulfate compound and hydrogen gas liberates. Hydrogen gas we have to represent its physical state, and we will also represent it is evolved in the form of a gas. And expressing precipitate formed during a chemical reaction, if any precipitate formed. Precipitate means it will not the substance will not soluble in water and it will be settle at the bottom of the test tube, so that substance we called as a precipitate. If any precipitate formed during the chemical reaction, while writing the chemical equation, the precipitate we have to represent with the downward arrow. Here in this following example chemical equation, silver nitrate plus sodium chloride, two compounds here, AgNO3 plus NaCl gives rise to silver chloride plus sodium nitrate, AgCl plus NaNO3. Here AgCl is the precipitate. If any precipitate formed, we have to represent with a downward arrow. Sodium nitrate is the aqueous solution. But silver chloride formed as a precipitate at the bottom of the test tube. Okay, so like this way we can make our chemical equation more informative by expressing their physical state, if any heat liberates or absorbed, if any gas evolved, and if any precipitate formed. If we can write all these informations while writing our chemical equation, including with all these, our chemical equation becomes more informative. Along with these, if any some conditions also helpful to progress the chemical reactions. If any temperature or pressure catalyst, if any catalyst is utilized to complete the chemical reaction. So all these also we have to mention while writing the chemical equation. Some of the chemical reactions will be continue in the presence of some pressure, in the presence of some temperature maintenance, and some of the chemical reactions will becomes fast in the presence of some catalyst. So whatever the conditions we are required to complete the chemical reactions, this everything also we can mention above the arrow or below the arrow. If you can look at this example, silver chloride gives rise to silver plus chlorine gas. In the presence of sunlight, this chemical reaction takes place in the presence of sunlight. Okay, so here sunlight we represent above the arrow. And again one more chemical equation, photosynthesis. This is nothing but a photosynthesis, the preparation of food by the plants. Plants utilize which gas for the preparation here? Carbon dioxide, and also use water. And in the presence of water, and chlorophyll, the green color substance present in the leaves. Due to the chlorophyll, the leaves appear in green in color. Only green leaves can prepare the food. So with non-green leaves cannot prepare the food. In green leaves, the chlorophyll substance helpful in the preparation of the food. The presence of sunlight and chlorophyll also need to prepare the starch or glucose in the leaves. So that's why sunlight and chlorophyll we mentioned above or below the arrow. And the plants utilize carbon dioxide gas, water, and produces and forms glucose or starch in the leaves, and they release which gas? Oxygen gas. This is the chemical reaction represents preparation of food by the plants, that is nothing but photosynthesis. Okay, so whatever the conditions are required to complete the particular chemical reaction, we can represent above or below the arrow mark. Okay, so like this way we have to represent our chemical equation more informative. Okay, thank you viewers.